We are going to start now the second lecture of chapter 4, class 10th mathematics, quadratic equations. In our previous lecture, we have talked about solving the quadratic equation by factorization method, and most of the problem they were based upon the method of splitting the middle term. Now the next method we have, it is by completing the squares. So what we are trying to do now is we are trying to write any quadratic equation in this form. We are saying any quadratic equation is given and we are trying to write it in this form. From this we will get the answer. It is ax plus b whole square is equal to c square. So it is ax plus b is equal to plus minus c. So we get the value of x is minus b plus minus c over a. This will be our final answer. These are the values of x that we will have. So our main motive over here is to write any quadratic equation in this form. That is why we are saying it is completing the square. Earlier, suppose I am talking about the general quadratic equation. It is a1x plus b1, it is a1x square plus b1x plus c is equal to 0. We are converting it to this form and we will see how we can convert it to this form. So we see the method with the help of examples. So the first equation we have, it is x square minus 10x minus 2 is equal to 0. Now what we want to do is we want to write this term as whole square. Writing this term as whole square means I am comparing it with x square minus 2 into 5x. This is equal to say 2. This constant term we have shifted on the other side. Now the formula we have, it is a minus b whole square, that is equal to a square minus 2ab plus b square. So it means if I want to, I compare these terms over here, we have this a is just like this x. I am looking at this term over here, it is 2 over here, this is 2 over here. A is just x. It means this value of b we have, it is 5. So basically the value of b, it is 10 by 2 is equal to 5. This is the value of b. So what we are going to do now, we are going to add b square on both sides. We are going to add 5 square on both sides of this equation. We are talking about this term over here, this 5 square and this 5 square we have added on both sides of this equation. So this whole term will become x minus 5 whole square, that is equal to, this is 5 is a 25 plus 2, it is 27. When we take the square root, we get x minus 5, that is equal to plus minus root 27. So the value of x that we will get, that is equal to 5, this we are shifting on this side, plus minus root 27. So it is two values we are obtaining. One is 5 plus root 27 and second is 5 minus square root 27. Square root 27 we can write it is 3 root 3. This is 3 square root 3. So the answers we are obtaining, it is 5 plus 3 root 3 and 5 minus 3 root 3 are the roots of the given equation. So what we have done, we have this equation and we have completed the whole square. We have written this equation so that this term is just like the whole square of some term. So we look at another example on our next slide. In this question, the equation we have, it is 3x square minus 5x plus 2 equal to 0. Now we want to complete the squares. So first thing we have to do is we have to write this term as whole square. So to write this term as whole square, we are talking about two methods. One thing you can do is you can divide this whole equation by 3. So suppose I divide this whole equation by 3, so what I will get, it is x square minus 5 by 3x is equal to minus 2 by 3. Now what we have? We are saying we have multiplied and divided this term with 2. We have added 5 by 2 into 3 square on this side, added 5 by 2 into 3 square on this side. We have added these terms on both sides of this equation. What this term will become? It is x minus 5 by 6 whole square. This is equal to minus 2 by 3 plus 25 by 36. So it is x minus 5 by 6, that is equal to, when we take LCM over here, 36 is the LCM, so it is minus 24 plus 25, so it is 1 by 36. This is whole square. So what we get is that x minus 5 by 6, that is equal to plus minus 1 by 36, so it is plus minus 1 by 6. So the value of x we have, it is 5 by 6 plus minus 1 by 6. This 5 by 6 we are shifting on this side. So the answer we get, it is 5 by 6 plus 1 by 6 and 5 by 6 minus 1 by 6. So from the first part, the answer we will get, it is 6 by 6 is equal to 1. From the second part we will get, it is 4 by 6, that is equal to 2 by 3. So we are saying we are having two values of x. One is 1, second is 2 by 3, and these are basically the roots of this equation. So this is one of the methods to solve the problem, that in the first step what we have done, we have divided this equation with 3. To complete the square, we have multiplied and divided this part with 2. Then we have considered this 5 by 2 into 3. We have added the square of this term, we have subtracted the, we have added the square of this term on both sides. We have solved and we have obtained the answer. Second thing what we can do is, this term is 3x square. To make this the complete square, we have multiplied this whole equation with 3. So this term will become 9x square, and I can write it is 3x whole square. I'm talking about this 9x square, I can write it like 3x whole square. This 15x we can write it is 2 into 3x into 5 by 2. Now if we look at this term over here, this is just like a square minus 2ab. Now b we have, it is 5 by 2, so we have added 5 by 2 on this, 5 by 2 square on this side and 5 by 2 square on this side, and on solving we have obtained the similar answer, that x is equal to 2 and x is equal to 2 by 3 and x is equal to 1. So we are saying 1 and 2 by 3 are the roots of the given equation. So it is up to you that how you want to solve these kind of problems. Either you can divide it with 3, that is by making the coefficient of x square as 1, or you can multiply it with 3 to make the coefficient as the whole square. Now next we have, it is 2x square, it is 2x square plus x minus 4 is equal to 0. So first of all we are dividing this equation with, we have divided the equation by 2. This term will become 2. Now the next step we have to do, we are multiplying and dividing this term with 2. We are saying this whole term over here, it is this term, now we have it is x by 4. So what we have done, we have added 1 by 4 square and we have added 1 by 4 square on both sides. So what our equation will become, it is x plus 1 by 4 square that is equal to 2 plus 1 by 16, that is equal to 33 by 16. This is the value of x plus 1 by 4 square. So x plus 1 by 4, that is equal to plus minus root 33 by 4. Why it is so? We are saying when x square equal to a square, it means x can be a or x can be minus a. Why? It is x square minus a square equal to 0. If I try to solve this equation, it is x square minus a square is equal to 0. It means x minus a into x plus a is equal to 0. It means it is x minus a is equal to 0 or x plus a is equal to 0. It means x is equal to plus a or minus a. We are not saying that if you have x square equal to a square, it will have two roots. We are not saying that the value is x is equal to a only. There are two values, one is x is equal to plus a and one is x is equal to minus a. Both of these will satisfy this equation. Similarly, when we are saying it is square over here, we are taking the square root. This plus minus sign is because of this square root. So we get it is, when we take the square root, it is square plus minus square root of 33 by 16. Both these numbers, they are positive. And if both these numbers are positive, we can write it like square root of 33 by square root of 16. Now what is square root of 16? It is 4, and we are obtaining the answer in this form. So the final answer that we will get, it is equal to x is equal to minus 1 by 4 plus minus root 33 by 4, that is equal to minus 1 plus root 33 by 4 minus 1 minus root 33 by 4. So these are the two values of x that satisfy this equation. So we are saying minus 1 plus root 33 by 4 minus 1 minus root 33 by 4 are the roots of the given equation. Now, as we have discussed in our previous case, you can solve by multiplying. Over here the solution is shown that we have multiplied this equation with 2. When we multiply this equation with 2, this is 4x square, so it becomes a 2x whole square. Next term we have written in this form. We have added and subtracted this 1 by 2 whole square on both sides, and we have obtained the values of x. Now next we have, it is 4x square plus 3x plus 5 equal to 0. So we can write it in the form, it is x square plus 3 by 4x is equal to minus 5 by 4. Next step we have to do is, we are multiplying and dividing it with 2. Now look at this term over here. This term is 3 by 8. So what we are going to do is, we are going to add 3 by 8 square on this side. We are going to add 3 by 8 square on this side. So our equation will become x plus 3 by 8 whole square, that is equal to minus 5 by 4 plus 9 by 64. Now for both these terms we have 64 is the LCM, and the value we get, it is 64 divided by 4 is 16, and multiplied with 5 we get the answer is minus 80 plus 9. So it is equal to minus 71 by 64. So what we see from this is that the value we are getting, it is x plus 3 by 8 whole square, that should be equal to minus 71 by 64. We are saying this is just like any number over here. Say it is y. So what we have is that y square is less than 0. We are saying this number over here, this number is negative and it is less than 0. So what we have is that y square is less than 0, and we know this is not possible for any real number y. If y is any real number, then this is not possible. It means there is no such value. We are saying there is no such value for which this number is negative. It means this equation has no real solution. This equation has no real solution. So the given quadratic equation has no real roots. So this is just like the situation we have seen earlier, that the equation of a quadratic equation we are talking about, or the quadratic polynomial we are talking about, it just represents a parabola, and this is just like the situation something like this. We know that root means where this parabola intersects the x-axis. We are saying there is no point of intersection over here. It means this parabola does not intersect with x-axis at any point. So we are saying it has no real roots. Now the next question we have, it is solve 10x minus 1 by x is equal to 3 by method of completing the whole square. So this equation becomes 10x square minus 1 over x is equal to 3. It means 10x square minus 1 is equal to 3x. So we can write this equation as 10x square minus 3x is equal to 1. It means this equation is x square minus 3 by 10x, that is equal to 1 by 10. So to complete the squares, we are multiplying and dividing this term with 2. Now this whole term, this is 3 by 20. So what we are going to do, we are going to write 3 by 20. We are adding 3 by 20 square on this side and 3 by 20 square on this side. We have added 3 by 20 square on both sides of this equation. So this whole term, this is the formula for x minus 3 by 20 whole square, that is equal to 1 by 10 plus 9 by 400. We take the LCM as 400, so we get it is 40 plus 9, so that is equal to 49 by 400. So what we get from this is, it is x minus 3 by 20 is equal to square root plus minus square root of 49 by 400, that is equal to plus minus 7 by 20. So the values of x we will get, it is 3 by 20 plus 7 by 20 and 3 by 20 minus 7 by 20. So it is 10 by 20, that is equal to 1 by 2, and the second value we get, that is equal to this symbol over here. It is minus sign over here. This is not plus sign, this is minus sign over here, and the answer you will get, it is 4 by 20, that is equal to minus 1 by 5. So we are saying that 1 by 2 and minus 1 by 5, 1 by 2 and minus 1 by 5 are the roots of the given equation. Now the next question we have, it is a square x square minus 3abx plus 2b square is equal to 0. So we can write it in the form ax whole square minus 3b We are saying this 3b term we have over here. Then it is ax. We are writing it is 3b ax, that is equal to minus 2b square. Now we want to complete the squares over here. So what we are going to do, we are going to multiply this with 2, divide this term with 2. This is ax whole square, we have ax over here. So what we are going to do is, we are going to add 3 by b whole by 2 whole square on this side and 3b by 2 whole square on this side. This whole term will become ax minus 3b by 2 whole square, and this term is minus 2b square plus 9b square by 4. So this becomes ax minus 3b by 2 whole square, that is equal to minus 8b square plus 9b square by 4, that is equal to b square by 4. So we get ax minus 3b by 2, that is equal to plus minus b by 2. So this gives us ax is equal to 3b by 2 plus minus b by 2. I am talking about this value. It has two values we have. It is 3b by 2 plus b by 2. This is 3b by 2 minus b by 2. So the answers we get, it is 4b by 2, that is equal to 2b, and this value is b by 2, that is equal to b. So these are the values of ax. So the values of x we have, it is b by a, and we are saying x is equal to, it should not be and over here, it should be or over here, that x can have the value b by a or x can have the value 2b by a. So we are saying that the roots of the given equation of 2b by a and b by a. Now next is x square minus root 3 plus 1x plus root 3 equal to 0. We have to solve this equation by method of completing the squares. So we are writing this equation in the form x square minus root 3 plus 1 x, that is equal to minus square root 3. Again we are multiplying and dividing this term with 2. We are adding root 3 plus 1 by 2 square on this side. We are adding root 3 plus 1 by 2 square on this side. This term, this is x minus root 3 plus 1 by 2 whole square, that is equal to minus square root 3 plus root 3 plus 1 whole square by 4. On solving this side, we get it is root 3 plus it is root 3 square plus 1 plus 2 root 3 by 4. This is equal to root 3 square plus 1 plus 2 root 3 minus 4 root 3 by 4. We have taken the LCM over here. This 4 and minus root 3, this becomes equal to this term. So this is equal to root 3 square plus 1 minus 2 root 3 by 4, and the answer we will get, it is root 3 minus 1 whole square by 4. We are saying earlier we are having root 3 plus 1 over here, and this term we are getting because this whole term, this is the sign over here, it is plus. In this term, when we have opened the whole square, it is plus 2 root 3. Then we have subtracted minus 4 root 3, and this term will become minus 2 root 3, and this is the formula of root 3 minus 1 whole square. So the value of x minus root 3 plus 1 by 2, this term we are talking about, this is equal to, we have to take the square root of this term. It is root 3 minus 1 square by 4. So we are saying it is plus minus. This square and square root gets cancelled and we are left with this root 3 minus 1, and square root of 4 it is 2. So we have two values of x. One is root 3 plus 1 by 2 plus root 3 minus 1 by 2, and second value we are saying x is equal to root 3 plus 1 by 2 minus root 3 minus 1 by 2. When we solve this equation, when we find the value of x is equal to this, we solve this equation, we get that the value of x we have, it is square root of 3. And when we will solve this value, that is root 3 by 2 plus 1 minus root 3 by 2, root 3 minus 1 by 2, we will get the answer is 1. So the final answers we are getting, it is that root 3 and 1 are the roots of the given equation. We get that root 3 and 1, these are the roots of the given equation. Next we are talking about the general solution of the quadratic equation, and this is we are talking about the quadratic formula. So the general quadratic equation we have, it is ax square plus bx plus c is equal to 0. Now to complete this case, we are trying to solve this equation, it is a is not equal to 0, by method of completing the square. So the first step we are writing it is x square plus b by ax plus c by a is equal to 0. So we can write this equation as x square b by ax is equal to minus c by a. We are multiplying and divided this term with 2. Now we have this term over here, so we are writing b by 2a whole square, we are adding on this side, b by 2a whole square we are adding on this side. This whole term will become x plus b by 2a whole square, that is equal to, when we solve this term, it is c by a plus b square by 4a square. Now by taking the LCM, we get it is 4a square is LCM, so it is minus 4ac plus b square. So the value of x plus b by a we have, it is square root of plus minus square root of b square minus 4ac by 4a square, and this is equal to plus minus square root of b square minus 4ac by 2a. This is value of x plus this. So the value of x we have, it is minus b by 2a plus minus square root of b square minus 4ac by 2a. 2a is in the denominator. So the LCM we have, it is 2a, and this value is minus b plus minus square root of b square minus 4ac. So the value of x we get, this is equal to minus b plus minus square root of b square minus 4ac by 2a. This term we are talking about, b square minus 4ac by 2a, this is called the discriminant and is written as capital D. So these are the values we are talking about. That one value we have, it is alpha is equal to plus square root b square minus 4ac, and second value we have, it is minus b minus square root b square minus 4ac by 2a. These are the two roots of this quadratic equation, and this value b square minus 4ac, this is called the discriminant, it is d is equal to this. So the condition for the real roots we have, it is b square minus 4ac should be greater than 0. Now we have some problem based upon this formula. So this equation is given to us, it is 9x square plus 7x minus 2. We have to find the roots of this equation. So the values we have over here, it is a is equal to 9, b is equal to 7 and c is equal to minus 2. The formula we have, it is discriminant is b square minus 4ac. It is 7 square minus 4 into 9 into minus 2. How we are getting this value? It is ax square plus bx plus c is equal to 0. So it is 49 minus, this minus minus will become plus, and this is 72, and the answer we get, it is 121, which is greater than 0. So we are saying there are two real roots, they exist. Now the roots we have, it is one root we are saying it is alpha is equal to minus b plus square root d by 2a, and second we have beta is equal to minus b minus square root d by 2a. So the values we get, it is minus 7 plus square root of 121 by 2 into a is 9, and beta we have, it is minus 7 minus square root of 121 by 2 into 9. So the answer we get, it is minus 7 into root 121 means it is 11 by 18, and this is minus 7, this is plus 11, and this is minus 11 by 18. So the final answers we will get, it is 2 by 9 and minus 1. So we are saying the required roots are 2 by 9 and minus 1. Next is we have to show that this equation has real roots and we have to solve it. So again, comparing it with ax square plus bx plus c is equal to 0. We get a is equal to 1, b is equal to 6 and c is equal to 6. The value of discriminant we have, it is b square minus 4ac. So it is 6 square minus 4 into 1 into 6. This is 36 minus 24 is equal to 12, and this is greater than 0. So this is our first part. We have to show that it has real roots. So we are saying discriminant is greater than 0. It means this equation has real roots. Now we are talking about the roots. So the value of roots, the formula we have minus b plus square root d by 2a, and the second root we have minus b minus square root d by 2a. So it is minus 6 plus square root 12 by 2 times a, minus 6 minus square root 12 by 2 times a is 1. Now when we are talking about square root 12, we can write it as square root of 2 into 2 into 3. This is equal to 2 root 3. So the answer we get, it is minus 6 plus 2 root 3 by 2, minus 6 minus 2 root 3 by 2. The value we have over here, minus 3 plus root 3. This is minus 3 minus root 3. So we are saying that minus 3 plus root 3 and minus 3 minus root 3 are the roots of the given equation. Next is show that the equation this has real roots and we have to solve it. Again, we compare it with ax square plus bx plus c is equal to 0. So we get value of a is 2, b is 5 root 3 and c is 6. So the value of discriminant we have, it is b square minus 4ac, that is equal to 5 root 3 square minus 4ac. So it is 25 into 3 minus 48, that is equal to 75 minus 48, that is equal to 27, and this is greater than 0. So this is the answer for the first part, that discriminant is greater than 0. It means that there are real roots. We are saying the condition is that discriminant should be greater than equal to 0. This is the condition for real roots to exist. This is the condition. Now we have to solve this equation. So to solve this equation, we are saying alpha is equal to minus square root by 2a and beta is equal to minus b minus square root d by 2a. So this is equal to minus 5 root 3 plus square root d is 27 over 2 times 2. It is minus 5 root 3 minus root 27 by 2 into 2. Now what is value of root 27? It is square root of 3 into 3 into 3, that is equal to 3 root 3. So the answer we get, it is minus 5 root 3 plus 3 root 3 by 4 minus 5 root 3 minus 3 root 3 by 4. So the final answers we have, it is minus 2 root 3 by 4 and this is minus 8 root 3 by 4. These two gets cancelled, so we are left with this minus root 3 by 2. These two gets cancelled and we are left with this minus 2 root 3. So these are the roots of the given equation. The next is using the quadratic formula solve for x. This equation is given to us. Now when we compare it with ax square plus bx plus c is equal to 0, we get a is equal to p square, b is equal to p square minus q square and c is equal to minus of q square. So the value of discriminant we have, it is b square minus 4ac, that is equal to p square minus q square whole square minus 4 into p square into minus of q square. So this is p raised to the power 4 plus q raised to the power 4 minus 2p square q square plus 4p square q square. So the answer we get, it is p square whole square plus q square whole square plus 2 times p square q square, that is equal to p square plus q square whole square. Now we are saying this is p square plus q square and whole square, and this value will be greater than 0 because it is square over here, and we are saying this is some real number. P square plus q square will be a real number, so square of this real number will be greater than equal to 0. So we are saying that this equation will have real roots, and the roots they are given by alpha is equal to minus b plus square root d by 2a and beta is equal to minus b minus square root d by 2a. So minus b is minus p square minus q square plus it is square root of p square plus q square whole square. This is value of square root d over 2a. A is p square. Similarly, it is minus of p square minus q square minus square root of p square plus q square whole square over 2 times p square. So it is minus of p square plus q square. This is, when we look at this term over here, this is square root of this term. So the value we get, it is plus p square plus q square over 2 times p square. The second value will be minus p square plus q square minus p square minus q square over 2 times p square. This p square gets cancelled. We are left with this 2q square over 2p square. So answer we get, it is q square over p square. In this case, we are saying this q square and q square get cancelled and we left with 2p square by 2p square. So the answer we get, it is minus 1. So we are saying that q square over p square and minus 1 are the roots of the given equation. Next is using the quadratic formula solve for x. This equation is given to us. So what we have now is a is equal to 9, b is equal to 9 into a plus b and c is equal to 2a square plus 5ab plus 2b square. Now to find the value of the discriminant, we are saying it is b square minus, this is b square In place of this, we are writing them as, this is as capital A, this is as capital B, and this is as capital C, because these small a, small b, small c, these are already in question, so we are writing them as capital A, capital B, and capital C. So the formula for discriminant, we are saying it is b square minus 4ac. So it is 4a into this term is c. So this value will become 81 into a plus b whole square minus, this is 36 into 2a square plus 5ab plus 2b square. When you will open all these terms, you will get it is 81 into a square plus b square plus 2ab. Then it is minus 72a square minus, it is 36 into 5, that is equal to 180 ab plus 72 b square. On solving these values, the answer we will get, it is 9a square plus 9b square minus 18ab. 9 we have taken common, it is a square plus b square minus 2ab. So the answer we are getting, it is 3 into a minus b whole square. Now again, this number, this will be greater than equal to 0. It means this equation will have real roots. So the value of d now we have, that is equal to minus of b. Minus of b means it is 9 times a plus b. Then it is plus minus square root of 3 into a plus, it is a minus b whole square and whole upon 2 times a. So the values we are having over here, minus 9a minus 9b. Look at this term over here, it is square root of this square term. So the answer for this term, it is 3 times a minus b. So it is plus 3a minus 3b by 18, and the second value is minus 9a minus 9b, then it is minus 3a plus 3b by 18, and this gives us that the two values we have, it is 2a plus b by 3 and second is a plus 2b by 3. So we are saying these are the two, a plus b by 3 and a plus 2b by 3, these are the two roots of the given quadratic equation. Now next, this quadratic equation is given to us. Now comparing it with the standard form, ax square plus bx plus c, we get the values of a, b, c, and the value of discriminant we get, it is b square. This is value of b we have minus 4ac. So we get, on opening this whole square, applying the formula over here, we get it is b square whole square plus ac whole square minus 2 times b square into ac plus 4 times b square into ac. We are saying this term we are talking about, this minus sign and minus sign, this will become the plus sign. We have this 4 over here, then we have these two b over here, it is b square and ac. So this whole term we are talking about, this whole term, this will become 2 times b square into ac with plus sign. So this is the formula for b square plus ac whole square. This is the value of discriminant. So the solution we have, it is alpha is equal to minus b plus minus square root of d over 2 times a. So minus b means minus b square minus ac plus minus when we are talking about d is this, so the value of square root d, it is b square plus a c. We are taking the square root, so square root d is b square plus ac, so we are getting it is b square plus ac upon 2 times a is a into b. On solving these values, we will get the final answer as alpha is equal to c by b and beta is equal to minus b by a. These are the two values we are obtaining over here. This is with plus sign, and this value we are saying this is the value we obtained by the, and we are considering the negative sign over here. So these are the two values we have obtained, and these are the final solution, that c by b and minus b by a are the roots of the given equation. Now next we have this question is given to us and we have to solve this equation. So first of all we are taking the LCM over here. So we get x into x minus 2, and this term is x minus 2 minus x is equal to 3. So this becomes minus 2 is equal to 3 x square minus 2x, and that is equal to 3x square minus 6x. So the quadratic equation we have, it is 3x square minus 6x plus 2 is equal to 0. Comparing it with ax square plus bx plus c equal to 0, we get a is equal to 3, b is equal to minus 6 and c is equal to 2. So the value of d we have, it is b square minus 4ac, that is equal to minus 6 square minus 4 into 3 into 2, that is equal to 12, and it is greater than 0. It means the real solution exists. Now the value of square root of d we have, it is square root of 12, that is equal to 2 root 3. So substituting this value in the formula, we get the value of alpha is minus b plus minus under root d by 2a. So minus of minus 6 plus minus square root, it is 2 root 3 by 2 times a. This is important to note over here, the value of b is minus 6. So we are saying it is minus 6 over here. This minus sign is because of this term over here. So this is equal to, if we are taking 2 common from the numerator, this term will be plus, so it is 3 plus minus root 3 by 2 into 3. So the two answers we have, one is 3 plus root 3 by 3 and second we have 3 minus root 3 by 3. Now next this equation is given to us and it is x minus 1 over x minus 2 plus x minus 3 over x minus 4, that is equal to 3 whole 1 by 3, that is 10 by 3. So if we take LCM over here, this is shown over here, it is x minus 1 into x minus 4. This term is multiplied over here, this term is multiplied over here, and the LCM we have, it is x minus 2 into x minus 4, and on solving this equation will come into the form this. When you will solve these all terms, this calculation, these are shown over here, and this becomes a quadratic equation in this form, and on comparing it with the standard form, we get a is equal to 2, b is equal to minus 15 and c is equal to 25. So the value of d we get, it is b square minus 4ac, that is 25, and square root of d then will become 5. So the value of alpha and beta, that is the roots we are talking about, you can use using the formula that alpha is equal to minus b plus square root d by 2a, and beta is minus b minus square root d by 2a, and the answers we have, it is 5 and 5 by 2. So we are saying the required value of x are 5 and 5 by 2. Next we have nature of the roots of a quadratic equation. So an equation is given to us, it is ax square plus bx plus c is equal to 0, where a is not equal to 0. then we have to write the nature of the equation. Nature of the equation means we are talking about when the real root will exist and how many roots it will have. So we are saying we have written this over here, that discriminant we have, it is b square minus 4ac. This condition we have already studied, that when d is greater than 0, we are saying the first condition we have, there are two things, either d is greater than equal to 0 or d is less than 0. We are saying when d is less than 0, there is no real root, and when d is greater than equal to 0, then two cases are there, either d is equal to 0 or d is greater than 0. It means when this is greater than 0, then roots exist. It is for sure that these roots, they exist. When it is equal to 0, then we have it is repeated roots, and when d is greater than 0, then we have that it has distinct real roots. What this thing means is, we are saying that when the value of d is equal to 0, then value of alpha, that is minus b, plus we are saying the value of alpha and beta we have, it is square root d by 2a. When d is equal to 0, this term will be 0 over here, and the value we have, it is minus b over 2a. It means alpha is equal to minus b over 2a and beta is equal to minus b over 2a. That is, both the roots, they are same, and this is the case for the repeated roots. If the value of d is greater than 0, then the two roots we have, one is minus b plus root d by 2a, and second is minus b minus square root d by 2a. So we have the case over here that we have this quadratic equation will have distinct real roots. These are the two distinct real numbers that we obtain. So it has distinct real roots. So this thing is mentioned over here, when d is greater than 0, then the roots are real and distinct. When d is equal to 0, then the roots are real and equal. These are also called the repeated roots, and the value is minus b by 2a. And third case we have, when d is less than 0, then the roots are imaginary. We are saying that the equation has no real roots. Now based upon these observations, this is our first question. It is, find the nature of the roots of the quadratic equation. This equation is given to us. So comparing it with standard form, ax square plus bx plus c, we get a is equal to 4, b is equal to minus 5 and c is equal to 3. So the value of discriminant we have, it is b square minus 4ac, that is minus 5 square minus 4 into 4 into 3. So this is 25 minus 48, that is equal to minus 23, and this value is less than 0. So we are saying that this equation has no real roots. Next question is, show that the equation x square plus ax minus 4 is equal to 0 has real and distinct roots for all real values of a. Now comparing this equation with ax square plus bx plus c is equal to 0, what we have is, the value of a we have, it is 1, value of b we have, it is a, and value of c we have, it is minus 4. So the discriminant we have, it is b square minus 4ac. So it is equal to a square minus 4 into 1 into minus 4. This is equal to a square plus 16. Now what we have is, whatever value of a we take, whatever real value of a we take for all real a square is greater than equal to 0. This means a square plus 16 is greater than 0. It means discriminant is always greater than 0. And if discriminant is always greater than 0, it means whatever value of a we take, the given equation has real and distinct roots, and this is what we have to prove. Next is show that the equation this has real roots and find these roots. So again we are comparing it with the standard form ax square plus bx plus c is equal to 0. So the value of a we have it is 2, b is minus 6 and c is 3. So b square minus 4ac, that is equal to minus 6 square minus 4 into 2 into 3, that is equal to 36 minus 24, that is equal to 12, and this is greater than 0. So we are saying that this discriminant is greater than 0. It means this equation has real and distinct roots. Now to solve this equation, we know the formula we have, it is that alpha and beta, the roots we are talking about, they are minus b plus minus square root of d by 2a. The value of d we have it is 12. So square root of d will be square root of 12, that is equal to 2 root 3. So the answer we are writing over here, minus b means minus of minus 6 plus minus square root of d means 2 root 3 upon 2 times the value of a we have it is 2. So the final answers we have, they are 3 plus root 3 by 2 and 3 minus root 3 by 2. These are the roots of the given equation. Next is find the nature of the roots of the quadratic equation this and hence solve it. So the value of a we have it is 3, b we have it is minus 4 root 3 and c we have it is 4. So value of discriminant that we have over here, it is b square minus 4ac. So it is 16 into 3 minus 16 into 3, that is equal to 0. So we are saying if d is equal to 0, it means the equation has a real repeated roots, or they have the equal roots. We are saying you can say it is repeated root, or you are saying they are equal roots, and the value of the roots that we have it is, the formula for the roots we have it is x is equal to minus b plus minus square root of d over 2a. The value of d we have it is 0, so it is minus b over 2a. So it is minus of minus 4 root 3 over 2 into a. So it is 2 root 3 by 3 and 2 root 3 by 3. So we are saying there are two roots, and both of these two roots, these are repeated roots. Next is find the value of k for which the quadratic equation has two real equal roots. Now the value of a we have it is 2, b is k and c is 3. So the roots we are talking about, the discriminant in this case, it should be greater than 0. It should be equal to 0. We are saying it has real equal roots. It means discriminant should be equal to 0. And the value of discriminant in this case, it is b square minus 4ac. So it means 0 is equal to k square minus 4ac. So it is k square minus 24 equal to 0. So what we get is k is equal to plus minus root 24. This is equal to plus minus 4 into 6, that is equal to plus minus 2 root 3. So the value of k we have, it is 2 root 6 and k is minus 2 root 6. It means for both these values of k, when k is 2 root 6 or k is minus 2 root 6, this equation will have the repeated roots. It is important to note over here that these are the two values of k, but this equation will have repeated roots, and that root will be given by the formula minus b by 2a. minus b by 2a means it is minus k by 4. So if k is equal to 2 root 6, this equation will have the root 2 root 6 by 4. If k is equal to minus 2 root 6, this equation will have the root minus of minus root 2 by 4. So we are saying for this value of k, it has repeated root, that is the roots it has minus 2 root 6 by 4. These are the repeated roots. For this value of k, it has the repeated roots. Next is find the value of k for which the roots of the quadratic equation this are equal. So you can write this equation in the form kx square minus 2kx plus 6 is equal to 0. So the value of a we have it is k, b is minus 2k and c is equal to 6. So the value of discriminant we have it is b square minus 4ac, that is equal to 4k square minus 4 into k into 6. Now what we want is that it should have equal roots. So condition for equal roots is that discriminant should be equal to 0. So we have 4k square minus 24k is equal to 0. 4k we take common, it is k minus 6 is equal to 0. So we are saying either k is equal to 0 or k is equal to minus 6. So we get when k is equal to 0, if we put k is equal to 0, then this equation will become 0 plus 6 is equal to 0, and this is not possible for k is equal to 0. Or what we can say, when k is equal to 0, this term will be 0 and we are not interested in these kind of values. So what we are left with is that this is not minus, this is plus 6 over here. When you solve this, you will get k minus 6 is equal to 0. This implies k is equal to 6. It means for k is equal to 6, this quadratic equation has equal roots. Next is find the value of k for this quadratic equation has two real equal roots. Again, it is given that it should have equal roots. So for equal roots, we are writing the discriminant for this equation, and the value of discriminant we get it is b square, that is k plus 1 whole square minus 4, it is a over here, and the value of c it is 1, and the discriminant we are saying it should be equal to 0. On solving this, we are getting it is k square plus 1 plus 2k minus 4k minus 16, that should be equal to 0. So we are saying it is k square minus 2k minus 15 should be 0. Now we have to find the roots of this equation, and to find the roots of this equation we are writing it is k square minus 5k plus 3k minus 15 is 0. We take k common, so it is k minus 5 plus 3 into k minus 5 is equal to 0. So we get k plus 3 into k minus 5 is equal to 0. So we get k is equal to minus 3 or k is equal to 5. So we are saying these are the two values, that is k is equal to minus 3 and k is equal and 5, for which this quadratic equation will have two real equal roots, that is it has repeated roots you can say, or it has equal roots. Next is find the non-zero value of k for which the quadratic equation this has equal roots, hence find the roots of the equation. Again it is equal roots, condition for equal roots we have to find. So we are writing the discriminant, it is, before writing the equation we are adjusting the terms of this equation. It is kx square plus x square, this is kx square plus x square minus 2k minus 1 x plus 1. From these two terms, if we take x square common, we are left with the terms in this form. So this is the value of this term, it is the value of b, this is a and this is c. So discriminant we have it is b square minus 4ac, and the value of discriminant should be equal for the answer to have the equal roots. So we get it is 4 into k minus 1 square minus 4 into k plus 1 equal to 0. So it is 4k square plus 4 minus 8k minus 4k minus 4 is equal to 0. These two gets cancelled. So we are left with this 4k square minus 12k is equal to 0. 4k we take common, so we are left with this k minus 3 is equal to 0. So we are having k is equal to 0 or k is equal to 3. Now if we substitute k is equal to 0, the equation will become x square. We are saying when we substitute k is equal to 0, our equation will become, and this term we are talking about, it is x square, then plus 2x plus 1 is equal to 0. And when we substitute k is equal to 3, we get it is 4x square, it is minus 8 minus 4x plus 1 is equal to 0. Now what we are trying to find is we have to find the non-zero values of k. So the non-zero value of k means that we are not interested in k is equal to 0, we are interested in k is equal to 3, and this is the equation we are talking about, and we have now to find the roots of this equation. Now to find the roots of this equation, it is 4x square minus 4x plus 1. So we are writing it is 4x square minus 2x plus 1 is equal to 0. We take 2x common, so it is x minus 1. It is 2x minus 1 minus 2x minus 1 is equal to 0. So what we get is 2x minus 1 into 2x minus 1 is equal to 0. So it is x is equal to 1 by 2 comma 1 by 2. So we are saying for the non-zero value k is equal to 3, this equation has the repeated roots 1 by 2 comma 1 by 2. Next is if minus 4 is a root of equation this, and this second equation is given to us, this is minus 4 is root of this equation, and the equation this has equal roots, you have to find the value of p and q. So if minus 4 is the root of this equation, it means this will satisfy this equation. So it is 4 square plus 4 into minus, this is p into minus 4. Minus 4 is equal to 0. We are saying minus 4 is the root of this equation, means minus 4 will satisfy this equation. So we get it is 16 minus 4, this is 12, is equal to 4p. So the value of p we get it is equal to 3. Now if we substitute this value of p over here, this equation will become, we're talking about this equation, on substituting this value of p, it is x square plus 3x plus q is equal to 0. Now it is given that this equation has equal roots, it means b square minus 4ac, that is equal to 0. So we get it is 3 square is equal to 4q. So what we get is that the value of q is 9 by 4. So we have obtained the value of p is 3 and value of q is 9 by 4. And this is what we have to calculate. Next is if minus 2 is the root of this equation, then find the value of k so that the roots of the equation this are equal. Again minus 2 satisfies this equation. It means what we have is that 3 into minus 2 square plus 7 into minus 2 plus p is equal to 0. So it is 12 minus 14 plus p is equal to 0. So we get p is equal to 2. Now if we substitute this value of p is equal to 2 in this equation, this becomes x square plus k into 4x plus k minus 1 plus 2 is equal to 0. So it is x square plus 4kx plus k square minus k plus 2 is equal to 0. Now it is given that this equation has equal roots. We are talking about this equation has equal roots. It means its discriminant, that is b square minus 4ac, this should be equal to 0. So it is 16k square minus 4k square plus 4k minus 8 is equal to 0. So we get this is 12k square plus 4k minus 8 is equal to 0. So this is 3k square plus k minus 2 is equal to 0. Now to solve this equation, we are splitting the middle term and we are getting it is 3k square plus 3k minus 2k minus 2 is equal to 0. We take 3k common, it is k plus 1 minus 2 common, it is k plus 1 equal to 0. So we get it is k plus 1 into 3k minus 2 is equal to 0. So we get k is equal to minus 1 or k is equal to 2 by 3. So the final answer we have that the required value of k are minus 1 and 2 by 3. Next is prove that both the roots of the equation this are real, but they are equal only when a is equal to b is equal to c. Now next we have to prove that the roots of the equation, this equation is given to us. We have to prove that they are real, but they are equal only when a is equal to b is equal to c. So how we can write this equation? If I am talking about this first term, it is x square minus a plus bx plus ab. This next term it is x square minus b plus cx plus bc, and next term it is x square minus c plus a x plus ac. So if we add all these terms, we get it is 3x square minus, this is 2 common, this a is 2 times, b is 2 times, so it is a plus b plus c plus ab plus bc plus ca, and this is equal to 0. So we have this 3 is a, this whole term we are saying this is x over here, this whole term we are saying this is b, and this whole term it is a constant term. So the value of discriminant that we have, it is b square, that is equal to minus 2 into a plus b plus c whole square minus 4 a c is ab plus bc plus c a. Now in solving this, what we get is this term we are saying this is 4 times a plus b plus c whole square, and this term is minus 4 into 3 into ab plus bc plus ca. 4 we take common from both these terms, so we are left with a square plus b square plus c square. It is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. From this term we have taken this 4 common, so what we are left with is minus 3ab minus 3bc minus 3ca. So the final answer we get it is 4 times a square plus b square plus c square minus ab minus bc minus ca. Now this term we can write it in the form, if you multiply 2 inside, it becomes 2 times 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. So it is 2 times a square plus b square minus 2ab. We have taken this is a square b square minus 2ab. Next we are left with plus a square plus c square minus 2ac plus b square plus a c square minus 2b c. We are having 2a square, these terms a square, a square. Next we have b square and b square, and last we have it is c square and c square. So these three terms, these are over here. Now what is this complete term? This complete term is a minus b whole square. This is written over here that this term is a minus b whole square. Next is b minus c whole square, and next is c minus a whole square. These are the three terms we are talking over here. Now what we have is these all terms. It is a minus b square, so this is some positive, or we are saying it is greater than equal to, we are not saying it is positive, we are saying it is greater than equal to 0. This is greater than equal to 0, and this is greater than equal to 0. So this thing shows that the roots of the given equation are real. The answer is greater than, it is greater than equal to 0. So it means the roots are real. So it means now we have two cases, either it is greater than 0 or it is equal to 0, and we are saying these values will be equal to 0 if all these values a minus b, b minus c and c minus a, all these three values, if these are equal to 0, this is mentioned over here. Now a d is equal to 0 implies the sum of these terms is 0. We are saying it is square on this, it is square on this, it is square on this. It means all these three terms, either they can be 0 or positive. So for all these terms to be 0, it means all these three terms should be individually 0. That is a minus b is 0, b minus c is 0, c minus a is 0. So the final answer we get is that a is equal to b is equal to c. So we are saying discriminant will be 0. That is that they have equal roots only when a is equal to b is equal to c. Now in this next question, we are given that if the roots of the equation this are equal, we have to prove that 2b is equal to a plus c. So if we solve this question using the discriminant method, you will not obtain this answer so easily. So in place of this, what we are going to do is, we are saying this is a bit different kind of question, you can say. This is not the ordinary question, this is a bit different question. So how we are going to solve this is, we are saying that x is equal to 1 satisfies this equation. This is by substituting x is equal to 1, we have seen that it satisfies this equation. So we are saying 1 and 1 are the only roots of this equation. It is given that if the roots of this are equal, it means the roots of this equation, it is 1 comma 1. That is alpha is equal to 1 and beta is equal to 1. Now what is the sum of the roots of this equation? It is alpha plus beta, that is equal to 2. That should be equal to minus b by a. What is product of the roots of this equation? That is equal to a minus b over b minus c. That is equal to, this is c by a. So on solving this equation, what we get is b minus c is equal to a minus b. So this gives us 2b is equal to a plus c, and this is what we have to prove. So you need not to worry much about these kind of questions. This is a different kind of question. It is not difficult to solve, but it has a very different approach to prove this thing. So this is just for your information purpose right now, that these kind of questions might also be possible, that it is not always necessary that the method of discriminant is necessary to solve every question. These kind of questions are also there. Next is, show that the equation this is not true for any real value of x. So we are saying this equation is given to us. If we calculate the discriminant for this, it is b square minus 4ac. So the answer you will get, it is 49 minus 96 is minus 47, and this value is less than 0, it means it has no real roots. It has no real roots. So we are saying that this equation is not possible for any real value of x. This is what we have to prove, that this kind of equation, it is not possible for any real value of x, means that there is no real value of x which satisfies this equation. Next similar question is there. This equation is given and we have to prove that this equation has no real roots. So we are calculating the discriminant over here. So discriminant we have, this is the value b, this is the value a, and this is the value c. So it is b square minus 4 a c. So when we solve this, we are getting it is 4 into a square plus b square plus 2ab minus it is 8 into a square plus b square. So the answer we get it is 4 a square plus 4 b square minus 8 a square minus 8 b square plus 2ab. This is minus sign we are taking common, so we are left with is minus 4 a square minus 4 b square, and it is 8 ab over here plus 8 ab. So if we take minus 4 common, what we are left with is a square plus b square minus 2ab, and this is equal to minus 4 into a minus b whole square. This term we are talking about, when we are looking at this term, we are saying a minus b whole square is greater than equal to 0. Now if a is not equal to b, it means this term is always greater than 0. It means when we are multiplying it with minus 4, it means this term is less than, it is always less than 0. It means the value of discriminant, whatever the values of a and b are, value of discriminant is always less than 0, and this thing tells us that the given equation has no real roots, that this given equation has no real roots. Next is find the value of k for which this equation has no real roots. So we are comparing it with ax square bx plus c. We are getting a is equal to 1, b is equal to 5k, and c is equal to 16. So the value of discriminant we will get it is b square, that is 25k square, into 4 minus 4 into 16. So the answer we have it is 25k square minus 64. Now what we are saying, that the value of d should be, we are saying the value of d should be less than 0. We are interested in those values of d for which those values of k for which d is less than 0. So we solve this equation. 25k square is equal to 64. We get k is equal to 64 by 25 square root. So what we get is, it is 8 by plus minus 8 by 5. We are getting this value that k should be plus minus 8 by 5. So we are saying for this value plus minus 8 by 5, the value of this equation, this is 0. Now we are interested in those values for which the answer is negative. What this thing means is, if suppose I am talking about this is the number line, somewhere over here it is the value minus 8 by 5, somewhere over here the value it is 8 by 5. At these 2 points the value of d is 0. The value of d is equal to 0. Now we are interested in those values for where the d is negative. So what we do, there is a point over here, say it is 0 over here on this number line. If we substitute 0 in this equation, we get that when we substitute 0 in this equation, we get that the value of d is negative. This is one of the methods to find the solutions. So what we are saying is that between minus 8.5 to 8.5, the more details of these kind of solutions you will study in your next class, in your class 11th, that how you solve these kind of inequalities. So we are saying basically this is the region, that is the value of k between minus 8 by 5 to 8 by 5 is there, for which this equation has no real roots. Because if you will substitute any point after this, suppose I am substituting 3, the value of k I am substituting 3, you will get the value of d is positive. If I am substituting the value of d is say minus 3, I am of k is minus 3, I am getting d is positive. So this is the complete method. You can refer to the videos related to inequalities, that how we find this. But right now you can see from here that if we substitute the values of k between minus 8 by 5 to 8 by 5, then the value of d will be negative, and this is the required answer. Next is find the value of k for which the given equation has real roots. So the first equation that is given to us, it is kx square minus kx minus 2, 6x minus 2 is equal to 0. So for this we have calculated the value of discriminant. It comes out to be 36 plus 8k, and we are saying that this should be greater than equal to 0. It has real roots, it means it may have repeated or non-repeated. Both cases are there. So we are saying it should be greater than 0. If we subtract 36 from both sides of this equation, we get it is 8k is greater than equal to minus of 36. So k is greater than equal to minus of 36 by 8. So this gives us k is greater than equal to minus 9 by 2. Similarly, for the second equation, we have calculated the discriminant. It is b square minus 4ac, and the answer we get it is 4 minus 12k. So we are saying 4 minus 12k should be greater than equal to 0. Now if we subtract 4 from both sides, we are getting 12k is greater than equal to minus 4. When we are multiplying this equation with minus 1, this sign will be reversed. We are saying if 2 is less than 3, then minus 2 is greater than minus 3. So when we multiply it with minus 1, we get 12k is less than equal to 4. So we are saying k is less than equal to 4 by 12, that is equal to 1 by 3. So we are saying for k is less than 1 by 3, less than equal to 1 by 3, we are having this equation will have real roots. This point is important to note over here, that why this sign is reversed, because this equation is multiplied now with a negative number. Now the third question we have, it is 2x square plus kx plus 2. So we calculate the discriminant, it is k square minus 16. So again we are saying to solve this equation, we are saying that k square should be greater than equal to 16. This implies us k is greater than equal to 4 or k is less than equal to minus of 4. Why we are writing this? Again, if we equate, how you can look at this answer, if we equate it equal to 0, you get two values of k. One is 4 and one is minus 4. You draw the number line. These are the number minus 4 and 4. Over here it will be 0, say it is 5, there it is minus 5. Try to put these values over here. When we put these values in this equation, we will see that when we substitute it equal to 0, we get it is d is equal to minus 16, that it is less than 0. So we are saying that if we substitute some value greater than 4, we will see that the value of d will be greater than 0. And when we substitute the value less than minus 4, we will see that the value of d is greater than 0. At this point minus 4, it is d is equal to 0. At this point d is equal to 0. So the final answer we obtain is that for k greater than 4 or k less than minus 4, less than equal to minus 4, d will be greater than equal to 0. For these kind of inequalities, these are called inequalities. These kind of inequalities you can refer to the chapter of class 11th mathematics. It is inequality chapter is there, and you will see how we can solve these kind of questions. There is a method called wavy curve method over there, with which you can find the with which you can solve these kind of inequalities. Next is determine the positive value of p for which the equations this and this will both have real roots. So we are seeing this equation and this equation both have real roots. It means discriminant of both of these, they are positive. Now if we calculate the discriminant of this equation, it is 4p square minus 4 into 64. And if we calculate the discriminant of this equation, it is 64 minus 8p. Now it is given that both have the real roots. If both of these have the real root, it means both these values should be greater than equal to 0. Now we have two equations. One is when it is greater than equal to 0, we are writing the equation 4p square minus 4 into 64. It is greater than equal to 0. Second is 64 minus 8p is greater than equal to 0. So this is p square minus 64 is greater than equal to 0. And this is, we are getting that 8 minus p is greater than equal to 0. This gives us p square is greater than 64, and this gives us that 8 is greater than equal to p. Now again, to solve this, we will draw the number line. We are getting when p square is equal to 64, then p is equal to plus minus 8. So there are 2 points over here. One is minus 8 and one is 8. We are saying that at these points the discriminant is 0. If we substitute 0 in this equation for the value of the discriminant, we are having, if we substitute p is equal to 0, we get that in this region we are talking about, for the points between these 2 points, the value of d we have, it is less than negative 0, that is negative. We are interested in those values of d for which the answer is positive. So we are saying for less than minus 8 and greater than 8, the answer is positive. These are the regions where d is positive, d is positive. Now in the question it is given that we want to find the positive value of p. It means we are not interested in this region also. We are only interested in this region. So from this we get that the value of p we have, it should be greater than equal to 8. From this equation we are having p is less than equal to 8. We are saying we have the common value of p. Now we have this equation, this first condition, it is giving us this first condition. This gives us that p is greater than equal to 8. This second condition gives us that p is less than equal to 8. It means common value of both these is p is equal to 8. That is, p is equal to 8 is the only value, positive value of p, for which both these equations will have real roots. So p is equal to 8 is our final answer.